Basically, our vision and our mission is to enable engineers just to make the parts that they need. As simple as that, without compromise, without thinking about how you have to make that. My name is Benny Buller, and I'm the founder and CEO of Velo3D. And we make 3D printing for metals that allows people to produce the parts they really need.
The first thing to understand is that Velo already has breakthrough technology that makes it possible to print previously unprintable parts.
When we first built the Sapphire, we didn't know if it was possible to obtain sort of what it was we were trying to do, whether or not we would be able to solve the engineering challenges to allow people to print what they really wanted to be able to print. Now that we knew that, the next question was always, okay, but I want a bigger part. Okay, but I want a cheaper part. And that's what the XC really gives you. It's all of the same capabilities that you get on the Sapphire, but it's that much larger and it has that many more lasers. And because of that, the total cost per part just drops dramatically.
This machine is meant to print huge parts for critical industries that no one expected was possible even just a couple years ago.
The Sapphire XC is utilizing 8 lasers of 1 kilowatt each, so it's 8 kilowatt production power compared to 2 kilowatt in Sapphire. So it can produce 4 times faster.
Just to have a bigger machine by itself, isn't that useful if it takes a month to get your part. You can make a part on a Sapphire XC using the entire build volume, but it'll only take a couple days. I mean, it's kind of beautiful to watch. You've got these 15 to 45 micron particles that are, being melted in this melt pool that's sort of just being dragged along, and it's a very violent process. You've got sparks coming out of it. You've got all sorts of, interesting ejecta, but at the end of the day, you're leaving behind this nice, smooth, fully dense metal that then solidifies together. And a lot of that was accomplished by making some, very innovative changes on the hardware side in terms of how we're depositing the powder on each layer that allows us to really blow open the design of what's possible to print.
Velo3D realizes the original promise of metal 3D printing parts of any geometry, being able to print those parts at low cost and have no compromise in anything that you're building.
So what is characterizing where we are now is growth that is really limited by our imagination and by the actions we take to take advantage of what we invented, and by the actions we take to invent more things that would enable our customers to use our technology even more.
Yeah, it's extremely exciting.
We allow our customers to make the parts they really want, they really need, at the quality that they need without having to compromise.
By leveraging and extending HP Multijet fusion technology for printing 3D plastics, HP Metaljet can propel your business forward with the most advanced metals 3D printing technology for mass production. Get ready to take on new jobs and unlock new revenue streams. Inside the printer, the carriage features 6 print heads arranged across 2 print bars. Up to 4 different nozzles can print HP binding agent in the same 21 micron grid on the powder bed, providing 4 times nozzle redundancy. The printing process starts by spreading a layer of metal powder. Then, HP Metaljet binding agent is jetted at precise locations onto the powder bed to define the geometry of single or multiple parts. The energy source helps evaporate liquid components and cure the material. Once printing and depowdering processes are complete, a high-strength green part is removed from the build unit and sintered using an industry-standard sintering solution. The loose powder is recovered from the HP Metaljet powder removal station and transferred to the HP Metaljet powder management station, where it is automatically mixed, sieved, and loaded into another build unit for the next job. HP Metaljet breaks through the productivity, quality, and cost constraints of existing 3D printing technologies for metals. Compared to powder bed fusion, HP Metaljet produces more isotropic grain structure in the sintered part, resulting in more uniform material properties. Compared to metal injection molding, HP Metaljet technology eliminates the time-consuming debinding process, freeing up to 20 hours from your workflow. Now you can accelerate innovative designs and products and efficiently produce high-quality 3D metal parts at scale. Get ready to experience unlimited capabilities. HP Metal Jet. Reinvent opportunities.
What is a moonshot? Why do we reach for the stars? For Desktop Metal, the production system has been our shot. A project so ambitious, so groundbreaking, that solves so many problems for manufacturing and the world. With breakthrough metal 3D printing at speed so unheard of that some people thought it wasn't possible. Now, after nearly $100 million in R&D, it's here. The most anticipated 3D printer of all time. Introducing the Desktop Metal Production System P50. This is the moment when decades of promise about additive manufacturing finally become reality. High throughput 3D printing, end-use parts that hold up to the highest standards at prices that compete with traditional manufacturing. With the power to de-risk supply chains, compress time to market, lower costs, and streamline inventory to produce once impossible designs across virtually every industry. Designs that enable explosive advances that can take us to the moon and beyond. What's your moonshot?